Elon Musk has unveiled an innovative and groundbreaking motor that has caused a stir in the industry. What sets this Tesla motor apart? How is it engineered? What capabilities does it possess? And why is a motor crucial for an electric vehicle? Join me in this video as we delve into Elon Musk's remarkable new motor that has astounded the entire industry. As the leading manufacturer of electric vehicles worldwide, Tesla continues to impress the automotive industry with their impressive research and development. The personnel at Tesla have now introduced their latest creation, with an ingeniously designed and intricately wired electric motor unlike anything seen before. Elon Musk has always been associated with exceptional achievements. In addition to being the CEO of Tesla, the world's premier electric vehicle producer, Musk holds the title of the wealthiest individual alive, with a net worth of $255 billion as reported by Forbes. However, unlike other billionaires, Musk's wealth is not squandered on lavish vacations but rather fuels his ambitions, including his vision of a global transition to clean energy, especially within the transportation industry, which is currently the leading source of greenhouse gas emissions. The focus on researching electric vehicle propulsion systems is undoubtedly paramount. Tesla's inaugural fully electric vehicle, the Roadster, made its debut in 2008. Despite being designed for the luxury market, it boasted equally impressive features as other high-end cars. The primary distinction, however, was that while conventional luxury vehicles relied on internal combustion engines, ICE, the Roadster utilized an induction motor. To penetrate a market predominantly dominated by ICE vehicles, the Roadster needed to possess additional capabilities or some form of uniqueness. It successfully achieved this by delivering an incredible range and establishing its iconic identity through its robust powertrain. Powered by its formidable induction motor, the Roadster showcased mind-blowing acceleration, achieving 0 to 60 miles per hour in a mere 3 seconds. Boasting an astonishing acceleration of 0 seconds and a top speed exceeding 200 miles per hour, the induction motor became the standard choice for the Roadster's production from 2008 to 2012. However, Tesla temporarily halted the production of Roadsters to make way for the development and manufacturing of the Model S. Another noteworthy motor technology employed by Tesla is the permanent magnet synchronous reluctance motor, known as the PMA-SYN-ERM. This motor combines the features of a permanent magnet motor with a synchronous reluctance motor technique and is utilized in the Tesla Model Y until Elon Musk introduced another remarkable motor as part of the Palladium program to upgrade the Model S and X. The PMA-SYN-ERM motor had been Tesla Motors' finest offering. Elon Musk himself referred to this motor as the plain carbon-wrapped motor, and claimed that it surpasses anything else in the world. In his own words, the plain carbon-wrapped motor is arguably the most advanced motor on Earth, rivaling only those found in specialized laboratories. To grasp the inner workings of this remarkable machine, let's begin by delving into the fundamentals. Put simply, a motor is an electronic device that transforms electrical energy into mechanical energy, specifically in the form of torque. But how does it accomplish this feat? When an electric current flows through a wire, it generates a magnetic field around it. By coiling this wire and positioning it between two magnets with opposing poles, the magnetic field of the wire interacts with the magnet's field, resulting in one side being pushed up and the other pushed down. This rapid alteration of polarity causes the wire to rotate, creating movement. The three primary types of motors, namely the induction motor, the permanent magnet motor, and the synchronous reluctance motor, operate based on this same principle, albeit with slight variations. For instance, a permanent magnet motor incorporates permanent magnets on its rotor, while the stator consists of a wire coil. By adjusting the power supplied to the coil with an alternating current, AC, its magnetic field can be controlled. This magnetic field interacts with the permanent magnetic field of the rotor, leading to rotational motion. In contrast, the induction motor does not possess permanent magnets. The windings of the stator create a rotating magnetic field, RMF, which induces current in the rotor coils, resulting in the generation of a magnetic field. Consequently, the motor spins as it attempts to align with the stratus RMF. The synchronous reluctance motor combines elements of both types but does not utilize permanent magnets, making it relatively more affordable. Tesla's Palladium program reached its peak with the introduction of the plaid carbon-wrapped motor. Developed in secrecy, the Palladium program aimed to enhance the appearance, design, and features of the S and X models. Last year, the remarkable plaid Model S was launched, showcasing impressive new functionalities. To accommodate the production of this groundbreaking motor, Tesla had to establish an additional manufacturing line in their Gigafactory located in Nevada. This new line featured state-of-the-art machines, exclusively dedicated to producing the innovative plaid carbon-wrapped motor. It is an extraordinary machine boasting unparalleled features that surpass anything that came before it. The motor has been constructed using carbon fiber, a material renowned for its lightweight and strength. As a result, the motor is so light that it can be easily lifted by hand. Weight is a crucial factor in electric vehicles, EVs, as heavier weight significantly reduces the range. Therefore, this motor adds no extra weight, allowing for additional components to enhance the car's aesthetics. Designing this motor posed challenges for the company, and even Elon Musk admitted during the presentation that, to the best of their knowledge, this is the first time a production electric vehicle has achieved such a feat. Regarding the motor with a carbon overwrapped rotor, Musk explained the difficulties involved due to the contrasting thermal expansion rates of carbon and copper. Creating a carbon overwrapped rotor requires winding it with extremely high tension, which is an exceptionally challenging task. However, the company recently built a specialized automated machine in Nevada specifically for this purpose, enabling them to successfully develop this remarkable motor. Now, it is time to explore the capabilities of the Tesla Plaid carbon-wrapped motor as a starting point, surpassing that of a conventional metal-bound motor. This magnetic field holds the key to its exceptional power. When we refer to a magnetic field being strong, it encompasses various aspects, including power output and RPM rate. A stronger magnetic field intensifies the attraction and repulsion between the stator and rotor magnetic fields, resulting in more vigorous torque and power generation. Elon Musk mentioned during the car's unveiling that the motor achieves high revolutions per minute, RPM. Furthermore, the carbon sleeves used in the motor restrict the expansion of the copper rotor due to radial acceleration, allowing for higher RPMs. RPM plays a critical role in both acceleration and speed for electric vehicles, EVs, and Tesla EVs are renowned for their impressive RPM performance. The new Plaid Model S showcases tremendous acceleration, going from 0 to 60 miles per hour in less than 2 seconds, an astonishing feat. Moving on to the next text, during the first road test with the Plaid Model S, the tires spin wildly within just a few meters, leaving behind a trail of smoke as they struggle to grip the high-friction tarmac. Elon Musk expressed his satisfaction, stating, "No production car has ever achieved 0 to 60 miles per hour in under 20 seconds. Additionally, the motor addresses another challenge. Typically, increasing torque leads to the issue of overheating. This concern applies not only to EVs but also to internal combustion engines, ICE, necessitating provisions to manage this inevitable factor. Remarkably, the Plaid motor achieves immense torque without any risk of combustion, thanks to its superb cooling system. Nevertheless, heat management remains a concern. Additionally, the motor boasts an outstanding powertrain. As we have witnessed, the carbon-wrapped motor epitomizes power, delivering a total output of 1020 HP. However, to unleash maximum power, it requires a carefully engineered powertrain, and the Plaid Model S fulfills that requirement. The tri-motor setup efficiently harnesses substantial power from relatively low current, with 2 motors propelling the rear wheels and a single motor connected to the front axle driving the front wheels. This powertrain has proven successful, and there are rumors that the next generation of the Roadster will adopt a similar design. However, the Model S has utilized the tri-motor powertrain since its initial production in 2012. Shifting the focus to the batteries, they are an essential aspect to discuss as the Plaid motor undoubtedly demands advanced battery technology. The battery module and packs underwent a redesign to enable higher power charging and discharging compared to previous designs. Charging and discharging capabilities are crucial for EVs. Faster charging power results in shorter charge times, and it is worth noting that reducing charge time is an ongoing challenge for EVs that they are striving to overcome. Waiting at the charging station for your car to fully charge is not something many are willing to do. Simultaneously, having high discharging power enables greater acceleration, which contributes to the impressive speed burst of going from 0 to 60 miles per hour in 1.98 seconds. However, it may surprise you to discover that the battery module used in the Plaid Model S is neither the intended 4,680 cells nor the 2,170 cells found in the Model 3 and Model Y. Instead, it utilizes the older 18,650 cells, which were employed in previous versions of the Model S and X, despite the newer 2,170 cells being available. Moving on to the next text, the re-engineered 18,650 Plaid batteries are actually more energy dense, even surpassing the current 2,170 cells by 50% in terms of energy per unit. However, this presented a significant risk. Packing too many energy cells into a confined space could result in catastrophic consequences in the event of an accident. To address this concern, Tesla reduced the number of battery packs from 16 to just 5, without compromising the energy density. The new design reportedly incorporates additional silicon, a technique planned for use in the production of the 4,680 modules, which further enhances its power. It's intriguing to consider whether these could potentially be the 4,680 cells concealed within the modified 18,650 format under the Palladium program. Numerous enhancements were implemented in the Model S, including a further reduction in the drag coefficient, which proves to be a highly beneficial adjustment. A lower drag coefficient significantly improves power efficiency and increases speed. In fact, the Plaid Model S boasts an impressively low drag coefficient of approximately 0.208, making it the lowest among all production cars currently available. However, the most noteworthy aspect is undoubtedly the Plaid motor itself. There are reports suggesting that Elon Musk intends to incorporate this motor in all future Tesla vehicles, including the upcoming generation of roadsters. The video clearly demonstrates that Elon Musk's groundbreaking motor is a game-changer for the EV industry. By the way, if you're interested in watching more captivating videos, simply click on the video located right above.